When you hear the word rational, rational, what do you think of when you hear the word rational? Rational. Ratio, right? Okay, so what's a ratio? What is a ratio? It's a fraction. Thank you. Okay, so guess what our exponents are going to be? What do you think our exponents are going to be? That's right, fractions. Okay, they're the same properties as regular exponents. Yes, except, thank you very much. Our exponents are going to be fractions. Now, this is going to be so much fun because we're going to be adding, subtracting, and multiplying fractions. I can't wait to insult you guys. All right, if I have the same base and multiplying two powers together, what do I do with their exponents? That's right, add them. So I have 1/2 plus 3/2. What's 1/2 plus 3/2? 4/2. Boy, we are on top of things today. What's 4 divided by, what's 4/2 simplified? 2. 4 divided by 2 is 2. What is 3 to the second power? Man, you guys are good. Okay, if I have a power raised to a power, what do? A parentheses with an exponent outside. That's right. I have to think of it as distribution, and I multiply them. So I have 4 to the 3/2 times 2. What do I get? Are you smarter than a fifth? 6/2. Thank you very much. 6/2. 4 cubed. You want to simplify that? 4 cubed is? Thank you. Okay, if I have a power with different bases, remember if I don't have an exponent there, it's a 1, right? So I have to multiply each exponent. There's actually an easier way to do this, but I'm not going to tell you. So I have 9 to the 1 times 1/2, which is 1/2, times 4 to the 1 times 1/2 is 1/2. Does anybody know how to make 1/2 into a radical symbol? It's the square root, right? Square root of 9 times the square root of 4. Square root of 9 is, what do you get? Thank you. With me? What about negative exponents? What do I do? How do I get rid of negative exponents from the past 2 days? Flip them. Put it over 1. So I'm going to flip it to 25 to the positive 1/2. What's the square root of 25? 5. It's actually plus or minus 5, but we're not going to worry about that right now. If I have fraction or division with the same base, what do I do with the exponents? What do I do with the exponents? That's right, subtract them. Okay, 5 halves, if I have 5 halves of something and I take away one of the halves, how many halves do I have left over? 4 halves, which is -1. 2. 6 squared is? That was perfect. What about dividing different bases raised to a power? So what do I do with them? Section E, this, and I'm not going to tell you. Yep, to multiply each exponent. So I get 8 to the 1/3 divided by 27 to the 1/3. 1/3 is cube, correct? Instead of square root. These two numbers are perfect cubes. Yes. 8 is a perfect cube of 2. And 27 is 3 cubed. So I end up with 2. It's a problem, you don't think, like when you put that costume on this morning. You really think you could come in here, sit down in that costume, and have me not make fun of you? Do you really think that was going to happen today? All right, let's do some example problem. Okay, number 1. I have the same base, multiplying them. So what do I do with the exponents? That's right, add them. 1/2, well, this is going to be fun, plus 1/4 is what? One half plus 1/4 is what? 1/2 plus 1/4. 3/4. Thank you very much. Did you use your calculator? Oh, speaking of calculators, oh, check this out. Check this out. Can you guys see this? Yeah. One of my students, this mosquito was buzzing around her calculator. And when she smacked it with a pencil, it killed the mosquito, but it splattered all this blood on there. See it? Isn't that cool? I want to show all my classes. Okay. Can I simplify this? No. So that's my answer. Nope. Huh? 1/2. Okay. Here. We're just gonna put it in a calculator. Okay, so I have 1/2 plus 1/4. Hit enter. Math. Enter. Enter. Now, back in the third grade, 4th grade, when did you guys do fractions? 2nd grade? If you're adding fractions, you have to come up with a common denominator. What's my least common denominator here? 4. To make 1/2, to make that 2 a 4, what did I do? Multiplied it by 2. Okay, 2 times 2 is 4, so I have to multiply the 1 times 2. Plus 1/4. 2 plus 1 is 3. My 4 stays the same. Are you good? Do you remember from 3rd grade? What? Yes. All right, number 2. Number 2, I have a powers, different bases, raised to a power. So what do I have to do? Multiply. Oh, this is going to be great. Okay, 8. What's 1/2 times 2? 1. Thank you. I get 2/2, which is what? Times what? 1/3 times 2. Everybody agreed? And I am not going to take the cube root of 25, so I'm just going to leave it as is. It's a messy number. It's messy. We'll get to it later. All right. I also have different bases. Negative exponent outside parentheses. Not only that, but we're going to have to deal with negatives. So I'm going to multiply each exponent. What's 4 times negative 1/4? -1. Very good. Okay. Do I need to review? 4 times negative 1/4. These cancel. 1, 1. Everything's 1 and a negative, so it's -1. Okay. Times 3. What's 4 times negative 1/4? Somebody did the hard work for you like 30 seconds ago. -1. Okay, how do I get rid of negative exponents? Put them below. So I have 2 times 3, which is 2 times 3. 2 times 3. 1/6. Number 4. 5. That's 7 to the first, right? Same base. What do I do with the exponents? Nope. We're dividing them. We're dividing them. What do we do with the exponents? Subtract them. Thank you. So I have one whole exponent there, and I have a third of an exponent. If I have the whole number 1 and I take 1/3 away, how many thirds do I have left? 2. You guys are on a roll now. You cannot stab the dumbass. Okay, number 11. Last one I'm doing. I have a power to a power, so I have to do what? Multiply. This is going to be so much fun. X 3/5 times 1/6. Ready, set, go. Anybody? Anybody? 1/10. Very good. You did it on your calculator, didn't you? Okay. 3 times 1 is 3. 5 times 6 is 30. Divide each one, simplify it, you get 1/10. I'm going to have to erase this video.